Hello everyone, welcome to this channel. This question is from Olympiad Pathfinder, Chapter 12, Build Your Understanding, question number 16. The question is, a particle of charge Q is placed on the axis of a neutral cylinder of volume V at a distance x from one end of the cylinder as shown in the figure. Here the distance x is much larger than the linear dimension of the cylinder. So using suitable approximations, find force F of electrostatic interaction between the charge and the cylinder. Considering the cases when the cylinder is of conducting material and second is cylinder is made of an insulating material of relative permittivity epsilon subscript r, epsilon r. Let us solve this question. What is happening? When the charge Q is placed at a distance x away from the cylinder, because of the electrostatic interaction, negative charge will start accumulating at this edge and positive charge at the farthest end. So the cylinder will become a dipole. We have notated that Q prime is the charge which is coming up on the cylinder due to induction. We have taken the length of the cylinder as capital L. So what will be the dipole moment of this? That cylinder after induction of charges will be Q dash into L, you know by definitions or by formula. Also you know that this dipole will create an E field at a distance x away on its axis that can be given with this formula K into dipole moment of the cylinder divided by x cube. So therefore the force of electrostatic interaction on charge Q will be, if we multiply Q with this E, we will be getting the force. So this is your equation number 1. Now let us we should deal with the cylinder of conducting material. In conductor we know that electric field inside it is 0. We have shown the magnified view of cylinder, though the cylinder is very small in comparison to the length axis, the linear dimension. So if E field is inside is 0, so which all charges are creating the E field inside? So that is due to the charge Q. So that we can write KQ by x square and the E field due to the induced charges inside will be sigma by 2 epsilon naught. But due to the induced charges, the E field will be in this direction, whereas due to the Q, the capital Q, the E field is in this direction. Since E net is 0, so we can write this equation. And we will further solve. So from here we can get Q prime, with how much induced charges has come up on the cylinder, and that is equal to this 2KQA by epsilon naught divided by x square. K is basically 1 by 4 pi epsilon naught. For the convenience, I have written it like this. So putting the value of q dash from equation 2 to equation 1. So this we set the equation 2. So if we put this value of q dash in equation 1 in the previous page, you will be getting the force as q square v by 8 pi square epsilon naught x to the power 5. So this will be your first answer. And this force will be attractive force because the negative charge is closer to the plus q charge, which has been kept an x distance away on the axis of the cylinder. So this will attract. When the cylinder is insulated with relative permittivity epsilon r, what will happen? The induced charge will become different. Now the induced charge, we should say that q double prime. And by formula, we know that q double prime will be the q prime when it was conductor into 1 minus 1 by epsilon r. So we will use the equation for force. In place of q prime, it will become q double prime, and we will put all the value, and finally we will be getting force is equal to q square by v 8 pi square epsilon naught x to the power 5 into epsilon r minus 1 divided by epsilon r. So this will be your answer for the second part. Again, the force will be attractive because the negative charge is closer to the plus q charge, the induced negative charge. So hopefully you understood the concept, and any problem, please write in the comment box. I'll clarify. Thank you.